have a circle, right? So if you can find the area of a circle, you can find the area of a semicircle with the same radius just by dividing it by 2, right? All right. So the area of circles. So that's the formula, top right-hand corner, pi r squared. Sometimes they'll ask you for the area of a circle in terms of pi. Today, everything we're working with is not passing it for it in terms of pi. In other words, we're replacing the pi symbol with whatever number they tell us. And today, they were telling us to replace it on all of these examples with 3.14. That's the approximation we're using for pi today. Not the exact number. Remember, pi is an irrational number, but that's what we're using today. So they asked us to find the area of a circle with a radius of 6 yards. Use the value 3.14 for pi and do not round your answer. Be sure to include the correct units in your answer. So the correct unit for the length of the yards here is yards. Anytime you measure something or you give the length of something, that's a one-dimensional unit of measure. Length is just yards. But when we go and we find the area of something, now we're using the length of that radius times another length. We are using 2 dimensions, so that is the length of the radius squared, basically, which means all of our answers are going to be, all of our units of measure, if you're finding the area of something, is going to be in square units with an exponent of 2, right? So the area of this circle, so this is our radius, is 3.14 times 6 squared. And you can just do that just like that on your calculator. 3.14 times 6x squared equals, and we get 113.04. It's not just yards though, right? We're not talking about just the length of a circle, right? That would be the circumference, the length around the circle. We're talking about how much space is covered by this circle, so that is yards squared. Any questions? Mostly today's lesson is 7th grade math. You should have seen it all in 7th grade math, maybe 8th grade pre-algebra. If you took 8th grade math or pre-algebra, it should have been in there as well. Example 2, find the area of a circle with a diameter of 16 centimeters. So we've got a circle, but they don't give us the radius. Remember, we need the radius. What is the radius of this circle if the diameter is 16? Anybody? 8. How'd you get that? Very good. So the radius is equal to the diameter divided by 2, and in this case, that's 16 divided by 2. So now we know that this radius is 8. From here to here is 8. From here to here is 8. So plug it into the formula. They still ask us to approximate pi with 3.14. And so we get the area of the circle is 200.96 centimeters squared. So far, so good? All right, let's keep going. So the area of concentric circles. So a circle inside a circle. A ring-shaped region is shown below. So the ring-shaped region is this part they have colored in here, the shaded region. Its inner diameter, so basically the circle that's made from the inner part of the ring, has a diameter of 14 yards. Its outer diameter has a diameter of 20 yards. They ask us to find the area of the ring-shaped region or the shaded region here. All right? Imagine maybe you are a tile setter and maybe you have been hired to tile the top of a fountain that's circular. There's a beautiful fountain here. They just got concrete here. Maybe they decide they want to put tile on it, make it even prettier. Okay? How much tile do they need? Well, we find the area of that ring-shaped region or that shaded region in our picture, and then they'll know how much tile to buy. Okay? we're doing here. So this says, in order to find the area of the shaded region, we're going to take the area of that outer circle, or I think of it as the big circle, and then we're going to subtract the area of that inside smaller circle. And that's going to give us the area of the shaded region. So the big circle has a diameter of 20. So what is its radius? What's its radius, Darren? Yeah. And the small circle has a diameter of 14. So what's its radius, Mael? The diameter is 14 from here to here. So what is this part? Sorry? Half of 14, that's right. So that would be 7. So now we plug the radius for both of them into this formula. So 3.14 instead of pi times 10 squared minus 3.14 times 7 squared. And we can do it just like that on the calculator, remembering to use the x squared button. So 3.14 times 10 x squared button minus 3.14 times 7x squared button equals. It's a pretty big fountain. Not humongous maybe, but pretty big. I've just turned that sticker into a fountain. In my mind's eye, that's a fountain. All right, any questions? Does it make sense that we would subtract the middle one, the smaller one from the big one? One of the ways, if it doesn't make sense, sometimes I describe it as, we don't want the area of that middle part. It's like if you took a pair of scissors, if you had this diagram on a piece of paper, and you just took a pair of scissors and you cut out that center part, then you'd only have the ring left, right? And so the way, instead of cutting it out physically, we can just subtract that area. It's the same thing. Any questions on 3? All right, let's look at example 4. A ring-shaped region is shown below. The inner diameter is 26 inches. The width of the ring is 4 inches. Find the area of the shaded region. Okay, so we said area of the big minus area of the small. We need the radius for both. Do we know the radius of the big? Do we know the diameter of the big? They don't give us either one of those, right? But they give us the diameter of this smaller one. Well, they also tell us that the ring is 4 inches wide. So everywhere from here to here is 4 inches. Does that make sense? So now we know from here to here is 4, and from here to here is 4. So the diameter of that outer ring, or the big circle, is 26 plus 4 plus 4, or 34. Does that make sense? So that's the diameter of the big circle. Does that make sense, Miles? So if we know the diameter of that big circle, now we know the radius of that circle is half of that. What's the radius of the small circle? Sorry? The inside circle. What's the radius of that? Very good. Half of 26. So now we're going to take the area of that big circle, and we're going to substitute 3.14 for pi times the radius 17 squared minus 3.14 times the radius of 13 squared for the inner circle, or smaller circle. I'm just going to do that on our calculator. What'd you get? What'd you get, Charlie? Oh, you got it, Charlie? What'd you get, Elizabeth? That's what I got. Anybody get something different? And that is square inches. So the shaded region is 376.8 square inches. This is the shaded region we gave. So far, so good? Okay. I wanted to find the area of this shaded region. And they told us this is 26, so we know this is 13, and this is 13. That's just the area of a semicircle, right? So we are going to have to find the area of a semicircle sometimes. Sometimes we're going to have to recognize that they have put two semicircles, but they cut a circle in half and just split them in a different direction. So it still covers the same area. So this is a semicircle, right? It is a circumscribed triangle inside that circle, or you could say it's an inscribed triangle, I guess. Yeah, I get those back and forth. Anywho, the triangle is inside half of a circle or a semicircle. So we need to remember that the area of a semicircle is just the area of a circle divided by 2, or times 1/2 if you prefer. So in this case, if we want to find a shaded area, it tells us that the semicircle has a radius of 9. So we can find the area of that semicircle and subtract the area of this triangle, because we're kind of doing the same thing, right? But you can find the area of that shaded part by cutting out the triangle, right? So if we take the area of the semicircle and subtract the area of the triangle, we'll have the area of the shaded region. So we got to remind ourselves, what is the area formula for the area of a triangle? Yeah, I don't think that's on your reference sheet. You do have to know the formula for the area of a triangle. Anybody remember it? Charlie? Yeah, they don't call it length on a triangle, though. We call it base times height, right? Yeah. Yeah. Base times height. So in this triangle, they tell us that the semicircle has a radius of 9. Well, that semicircle they show us, that radius they show us, is perpendicular to the diameter of the semicircle, which is the same as the base of this triangle. So where the base and height of a non-right angle or a right triangle is one side, and the distance from that side perpendicularly to the vertex or point, even with that vertex, right? So this is the height, and the base would be 18. Does that make sense? If they tell us this radius is 9, we have to know that this is also a radius of that semicircle. This is also a radius of that semicircle. Does that make sense, Swan? Okay, so now we know we have the base and the height of our triangle. So the radius, it tells us, is 9. So now we're going to take 3.14 times 9 squared divided by 2 and subtract the area of the triangle, which is the base, times the height divided by 2. What'd you get, Thomas? What'd you get, Xavier? What'd you get, Elizabeth? What'd you get? I didn't get either one of those. What'd you get, Thomas?
I got 46.
Yeah, that's what I got. Try it again. And it sounds familiar from earlier today. So double check it. We always double check. Anyway, always double check your calculator work. 46.17 centimeters squared. So that is that little bit of shaded area in the semicircle. Questions on example 5? Let's look at example 6. There are three semicircles. Three semicircles are placed in a rectangle as shown below. The length of the rectangle is 36 meters. Find the area of the shaded region. Use value 3.14 for pi and do not round your answer. Be sure to include the correct unit in your answer. Well, above we did the last example is not on this slide. We did big circle area minus little circle area to find shaded region. This example 5, we did the area of the semicircle minus the area of the triangle to find the shaded region. Now, to find the shaded region, the semicircles are all inside of the rectangle. So the rectangle is where we start. We have to find the area of that entire rectangle and then subtract the area of 1, 2, 3 semicircles. Does that make sense? It tells us that the length of the rectangle is 36, and it gives us that each of the diameters are 12. We know that all the semicircles have the same diameter, so all the semicircles are going to have the same area. Does that make sense, Kellen? Does that make sense, Tori? Okay. So the question is, we're finding the area of the semicircle. We are going to need the radius. So we have to know if this is the diameter, then half of that diameter is the radius, right? So this is a radius, this is a radius, and that means from the center of that diameter to the edge of the circle is also a radius. So we know that the width of this triangle is 6 meters. So we do have to remember the formula for the area of a rectangle is length times width. Also, do not give you that on the reference sheet. They do give you a parallelogram in a rectangle is a parallelogram, so they call it base times height again. But length times width is how we normally learn that for rectangle. So if I find the area of that rectangle, we know the length is 36, and now we know the width is 6 meters. We subtract the area of 3 semicircles. So the area of the rectangle minus 3. The width? Oh, here? Erase this. What they gave us, and I filled in the other 6. What they gave us is this length here. They told us that each of these, basically it's the diameter of the semicircle, right, is 12. So we know if the diameter of the semicircle is 12, then the radius of the semicircle is 6. All right? So if this is 6, this is 6, any point from there to there is 6, right? So this would be the same length as a point from here to here. It's just half of 12. So the area of the rectangle minus the area of 3 semicircles is equal to the area of the shaded region. So the area of the rectangle, length times width, is 36 times 6, minus the area of the semicircle 3 times. We're going to do times minus 3 times 3.14 times the radius of the semicircle. So the radius of the semicircle, we're just going to call it a circle here, is 6. And then divided by 2, because it's a circle area divided by 2. So we can do that on our calculator. 36 times 6 minus 3 times 3.14 times 6x squared divided by 2 equals. And I got 46.44. Tell me if you got something different. What you got? Alicia got, Lyndon's got something different? Let me try it again. So 36 times 6, that's 216. We'll just double check. And then 3.14 times 6 squared divided by 2 is 5652. Now subtract those. Oh, what did I do? Did you okay? Okay, hold up top. Oh, I forgot to multiply by 3 times 3. Alright, so that then times 3. Yeah, it is 46.44 meters. Did you get that when you redid it, Elizabeth? No, alright, I'll show you. I'll do it with you. So 36 times 6 minus 3 times 3.14 times 6x squared divided by 2 and equals. Okay. Any questions? All right. I don't have your notes published, and it's purposeful. I forgot for second period, but then they couldn't stop and scan today. I want you to work your homework. But before we do that, we talk about a couple of things that I did not talk about until second period started. All right. So we said we know a circle divided by 2 is a semicircle, right? So one semicircle, one semicircle. Make sense? Sometimes on your homework you're going to see the circle, and it's going to look like that. That's still a semicircle and a semicircle. So the area, that's the same. Does that make sense? Okay, so the way we're going to see it today is we're going to have that shape. This is the shaded area, and you're going to find the shaded area by finding the area of the square and subtracting the area of the circle. Just split it in half and flip it, but it takes up the same amount of space that way, right? Another thing you're going to be talking about today, on today's assignment, is a quarter circle. So one of the diagrams looks like this. You have a square, and it tells you there are 4 quarter circles in here. And I'm not going to do a great job of drawing it, but it tells you that these are quarter circles. How many circles is 4 quarter circles? How many dollars is 4 quarters? $1. So 4 quarter circles is 1 circle. All right. So this would be the diameter of the circle, and then each of these would be the radius. Does that make sense? Same premise. You can cut it up and turn it around, but it's taking up the same amount of space. All right. Here's a common sense one. Let's say there's 20 kids in class, and I want to buy pizza. I'm not saying no pizza, it's just clarifying. What if I did buy pizza, and I needed 20 pieces of pizza, and each pizza usually has 8 slices in it? Would you agree? Typically, that's the standard. Anybody here work at a pizza place? That's the standard. There's 8 slices in one pizza, unless they tell us differently. How do I figure out how many pizzas I need to feed us? I need 20 pieces, and then there's 8 slices in each, and one pizza. So how many pizzas should I order? Can I order? Will 1 be enough? 1 will be 8 pieces, right? Will 2 be enough? 2 will be 16 pieces. Will 3 be enough? It'll be more than we need, but that's the only way to get enough to feed us all of y'all piece of pizza, right? All right, so the shortcut to this is just divide by 8, right? Oh, sorry. 20.8. All right, so 20 divided by 8 is 2.5 pieces. Can I go to Hungry Howie's? Cheap. If I were going to buy pizza, it would be Hungry Howie's. And it would be the pepperoni with a little cup pepperoni, it would be the duo pepperoni. It's my favorite one right now. Okay? So if you were ever to get pizza from me, that's what you're going to get. Can I say, hey, Howie, I need 2.5 pieces? No. If I want to make sure we get enough for everybody, how many pieces do I have to order? 3 pieces. So you have to remember that common thing with the day homework. If you need gallons of paint to paint our lovely watercolors instead of tile, right? What's the area of that? You're going to find the area of that. And then if they tell you, well, the paint that you want covers 10 square feet in every can. How many cans do you need? Right? So you're going to divide the area by however much area can be covered in the one can, and then you know how many cans you need. But unless it's an exact amount, you always have to round up to the next can. Everybody gets that all messed up, because when they divide it, let's say around at the end 8.129. Everybody's trying to round it here, right? This is the number of cans, though. I can't buy 0.1 cans, 8.1 cans. I can't buy 8.12 cans. I can't buy 8.13 cans, right? What if I buy 8 cans? What if I bought 2 pieces? Would that be enough? I don't want to round down, or I don't have enough. You always have to round up. You don't use the normal rounding idea when you're buying something that can't be split. So this is the common sense application of what we're doing today, all right? I think I've mostly hit on everything. Mark said, go. You didn't need something you're right on or right with? Oh, that's a long video with nothing on it.